I'd like to talk to you today about Mirolin Acrylic products. Mirolin manufactures acrylic products in Toronto, Ontario and in Airdrie, Alberta. A number of years ago, our Vice President of Manufacturing and our President were visiting Europe, talking to one of our sister companies, sharing best practices, talking about our business and our industry. And as they're walking through the manufacturing facility, something struck them as a little bit odd. Something very different than what happens in North America. In Europe, bathware manufactured using acrylic sheet is not actually reinforced on the backside with fiberglass. And the reason for this is that governments over the last number of years in Europe have encouraged manufacturers to reduce the amount of emissions and pollution that they're putting into our environment. And so these manufacturers went back to their acrylic sheet supplier and suggested to them that they needed product that was a little bit different than the cast acrylic sheet they had been using for a number of years. The suppliers came back and offered the bathware manufacturers what is known as engineered acrylic. And engineered acrylic takes all of the wonderful properties of acrylic: non-porous, scratch and stain resistant, UV resistant, high gloss finish for the lifetime of the product, and marries that with the strength and rigidity, but also flexibility that you get out of ABS. If you can imagine an ABS pipe and trying to crack that over your knee or smashing that against the ground, the pipe itself is very strong. So what it allows us to do is take those great qualities of acrylic and marry them with the strengths of ABS. And as such, we get what is known as engineered acrylic. What I want to show you today is some of the strengths that are in this material inherently. So when we take this wall, we have the ability to push it back or inward. What you're hearing is that crackling sound is the fiberglass reinforcement on the back of this product. As those bonds snap, the air pockets release, okay? And that crackling sound starts to diminish, okay? Again, when we flip to this wall, you'll hear the crackling sound. That is not the acrylic sheet breaking. Traditionally in cast acrylic product or fiberglass, we would see a crack right along this lower line here, okay, as we flex the wall. This material is incredibly forgiving and allows us to take the walls and flex them in or push them out as we might see necessary, okay? This type of product is big and bulky and not very easy to handle. It's not uncommon for it to tip over either due to mishandling or wind. When something like that happens on traditional cast acrylic or fiberglass product, it's very common that the product has been damaged, either spidered up the back wall or enough damage that it can no longer be installed. Not only is that costly in terms of real dollars, in terms of replacing the product, but also costs the contractor a lot of money and headache in terms of downtime on a job site. So it is possible that we broke this product. It is absolutely breakable, but 9 times out of 10 we're able to lift this product back up and go ahead with our repair. So let's take a look. Product looks okay. No damage on the back wall. Top flanges all seem to be in good shape. It's not uncommon that you'd get a small crack through the tile flange at the top here, okay? However, generally speaking, that's not something that would slow down an installation as you get drywall and tile in front of the flange eventually. One of the things I'd like to point out here is all of the sheet itself comes to us from the manufacturer with this microfilm on it. Okay? What that means is that it can easily peel away any of the dirt and mildew, spackle or paint splatter on the product that falls during the installation process. Another thing I'd like to show you is all of the tile flanges on Mirolin showers and tub showers are devoid of fiberglass. The reason for that is the acrylic sheet itself is very, very strong and does not require any additional reinforcing, okay? So it limits the amount of fiberglass we spray. But also, more importantly, you can take your stud wall and put it up against the side of the tub shower and get a nice smooth finish. No need to pre-drill, and just put your screw through the flange, okay? What I want to show you here is that what's sitting forward on this product is simply the 2 thin flanges, okay, on this tub shower. And the reason that's important is because as I tip this product over, tipping the unit over, we can now see that the unit itself is supported exclusively on these two flanges. On traditional cast acrylic product or fiberglass product, the flanges themselves would have completely disintegrated. Okay? Not only does this support those flanges and the acrylic strength itself support the weight of the tub, but it also supports my weight. So we can walk back and forth across this product. Okay? We can flex the product and it comes back to its normal. Okay. I'm standing in places on this product where there's a significant number of curves. The reason for that is the curves themselves provide strength to the product. However, when we look at the back wall section, completely flat, and also the area where the acrylic is stretched thinnest. Okay? This is the weakest point of the tub shower itself, and again, very easily handles my weight. Okay? Again, with cast acrylic or gel coat product, this would be virtually impossible. Before we flip the product over to see if we've caused any damage to the acrylic, I want to point out a few things on the underside of the unit. We've got wood reinforcement to keep the bottom of the base very strong. You'll also notice that there's a score in the base itself, and the reason for this is the bottom of a bathing well has to drain to the drain location, and in order to do so, we see the bottom of the bathtub is sloped towards the drain, but also curved. And if we were to take a flat piece of wood and put it on a curved surface, inevitably we're going to get gaps through the product. So what we've done is we've scored the product to allow the base to conform to the shape of the bathing well. Another thing you'll notice is what we call a bottom out leg. This leg is intended to sit a 1/16 to an 1/8 of an inch off the floor. The reason for this is as we fill the bathtub with water and we put someone in the tub, this tub naturally will want to flex. Okay? This bottom out leg will ensure that the maximum that bathing well is going to move before it hits your floor is an 1/8 to a 1/16 of an inch, essentially a negligible amount. We also bring this wooden base up around the drain. The reason for this is to avoid overzealous plumbers or installers over tightening the drain, pushing that drain up and creating a crown. What that means is that water is never going to drain from this bathing well. You'll also notice the wood structure at the bottom of this tub shower. Okay? There's a significant amount of structure here to make sure that the flanges stay strong and the apron itself is in a rigid position. So we can see where I was standing on the product, flexing the towel bar. This is the area that was depressed and then popped back up. This is that thin area on the back wall that I had walked through. You can see that there's no cracks through the product, nothing in the bathing well as well. Okay, very rigid, strong product that easily took my weight. One of the things that we commonly saw on a job site was alcoves that were made a little bit smaller, framing dimensions that maybe were made a little too small, and contractors inevitably on a job site determined to get the product installed would take their boots, push it into place. As often as we tried to ask contractors to change the way that they installed the product, it became evident that what we needed to do was change the way we built the product to live in the contractor's world better. A very common place that we see this product damaged is on the flanges themselves. As you're walking into a room or up the stairs and you bump into a stud frame. Okay, so these flanges are actually quite strong. They're absolutely breakable. But you can see the kind of force it takes in order to break them. Just walking into a standard stud wall is not likely to break this product. Okay? What I also want to show you is this product does actually take quite a bit of abuse before it will break. And I want to break it here because I want to show you how it breaks. But until then, So we can see the product does break, but what I want to point out is the way it breaks. If we looked at a point of impact from the hammer on cast acrylic or on gel coat product, essentially what we would see is a starburst or a spider pattern. And what that means is that from a point of impact, okay, you get cracks shooting in a number of different directions. As opposed to what you've seen here, where at a point of impact you get a very clean break, not necessarily a nice easy pattern to repair, okay, but it is a single line, single break. So for a repair person coming in to handle this type of product, they've got a jagged repair to fix, but it is only one. When we look at a starburst or spider pattern, you go from a point of impact and spraying outwards, and that repair person now has a number of cracks to contest with. This, theoretically, should be an easier repair. So that's engineered acrylic, again manufactured in Toronto and Airdrie in all of Mirolin's facilities. Thank you.